Hello everyone, and welcome back to another GIS statistics video. And in this video, I want to sort of move beyond our talk about the first order nearest neighbor analysis, and I want to talk about the second order nearest neighbor analysis. And this is probably going to be the most important part of this entire point pattern discussion is the second order nearest neighbor analysis. This is going to be the most commonly used example you're going to see. It's probably going to be the most commonly used example you're going to run. It just is sort of the default metric, right? All these other things, kernel density estimation, which we'll talk about in a bit, is also pretty useful. But by and large, this second order nearest neighbor analysis is one of the gold stars of point pattern analysis. And the one that we're going to be talking about is the most common second order nearest neighbor analysis, and that is what's called Ripley's K. Now we're going to be doing a slight modification, so it's actually going to be the L function, but they're interchangeable. L function is just you take the square root of k divided by pi, essentially. So anyway, what we can do is we can use this to determine spatial pattern in much the same way that we did the first order, but we're asking a slightly different question. Right? In the first one, we were looking at, how many points have their nearest neighbor within a certain distance, right? What Ripley's K is asking is how many points are within a certain distance. Let me make certain look a little bit better. Right, so now we're not just talking about 1 point, we're talking about how many points are within a certain distance. Of another point. Okay. So this is going to become slightly more complicated in terms of the approach that we take to calculate it. But basically, we're moving beyond just caring about the nearest neighbor to now we're caring about all the neighbors. And we're saying, well, given this point, how many neighbors do I have that are inside of this distance? And the direct interpretation is no longer a probability. The direct interpretation is a little bit more complicated, and it's also not as important because we're ultimately, again, we're going for that expected value and looking at that relationship. So what I want to do is I want to sort of hammer home this idea that Ripley's K is sort of shifting the question away from, is my nearest neighbor within this distance to, well, how many points do I have next to me in this distance? So let's go ahead and let's look at how we implement this in sort of a generic framework. All right, so the first thing we're going to do is we're going to calculate all the distances. Right, so before, right, we only calculated the nearest neighbor, which was the distance from one point to its closest neighboring point. Well, now we're going to have to keep track of all of the distances. All right, then we're going to pick some distance r and compare it to all the distances. Three, divide by the area, or divide by the number of points. Now this is where it gets a little tricky, and this is where the interpretation becomes a little bit cumbersome. All right, so we divided by the number of points. Now we have the proportion of the number of points within the distance relative to the total number of points, and then we're going to multiply by the density. Right, and that density again is m over a. Sorry, we're going to multiply it by the inverse density. So m over a. So this would become a over m. Right, we're inversing the density. And this is the part that really makes the interpretation of the actual value a little bit confusing. All right, 5. Increase distance and repeat steps 2, 3, 4, and then finally we're going to plot the results. Okay, so again, sort of this is the conceptual framework that we're going to go for. And again, we're trying to address this sort of generally, right? Again, the K is not interpreted as this, but we're generally going after, right? How many points are within a certain distance? And then we're doing all sorts of muckery in terms of multiplying it by some constants. But the general idea, Ripley's K, is figuring out, how many points are within a certain distance. And then we're going to do the exact same thing we did with the first order. We're going to plot it, we're going to calculate what we would expect, and we're going to compare the two. So hopefully this video made sense. If any of this was confusing, I promise you it will make more sense when we go through the equation. But as always, please reach out. Thank you.